Okay, can someone confirm that my screen is visible? Okay. So, in today's lecture, we are discussing the various ways how we can interact with the servers, the web, how we can reach the web from inside the React. As a pretext to the whole topic of this discussion, I want to remind you that the React.js is indeed a library, as it's stated on their official website. So, and today's lecture is one of those lectures that will reveal the actual meaning that the developers, the Facebook team, put behind the reasoning of library naming. And to put it simply, React.js is a bare minimum library that gets stuff rendered on the screen. So without any routing logic built in, without any Ajax logic. And the part of the routing logic you've covered in the previous lecture, and today's lecture is about the Ajax logic. So this is me again, Dmitry, with you today. And the whole agenda for today's lecture will be, first, we'll cover what is Ajax in general, not in terms of like the whole definition, but at least why we need a separate thing that helps our UI library to reach the web. Then we'll cover like a bit briefly Fetch API and how we can actually use it inside our React application. Then goes Axios, which is a library, a special library, a very commonly used library in the production environment and in fact in general development because of the ease of use of that library. And then we'll wrap up, pun intended, with API wrapper that hides away the details about the ways that we are reaching the web in our React project. And today's lecture will be more of a hands-on experience. So let me just go briefly to a terminal and start a typical command that most of the React applications are based on, which is installing and using in PX create React app. So create React app is in fact a boilerplate for all the React applications. So if you Google create React app, you will actually stumble upon the very page of the documentation that describes the needs of create React app, or CRA in short, and describes the common tools that are included in the boilerplate of the React application, the create React application, and then tells you how you can use it in different situations, be it a SPA, a MPA, or even a server-side rendered website. So a very handy tool, and it takes some time to install the whole thing. So I'm just gonna press it and come back to the slides. So first we'll start with Ajax. And if we want to actually summarize what Ajax is in short, it's just a set of technologies that allow a client, be it a browser, to access the server in search of data that it needs to render. So before that, with the traditional web applications, we had a very cumbersome way of retrieving some information from the server in terms of HTML files, and everything included in those HTML that get returned from the server other stuff that we need. So a typical way to get some stateful data in our web applications would to just request another page. Or if we wanted to post something to the server, we would use some kind of form, and a very standard way of submitting a form, which is actually even built into a browser itself. And it happened no matter what library or what framework you were using. So every time you did that, you needed a way of retrieving the data. You get a post request, you get a get request from the web, and it's all done with plain HTML. And the thing is, when you receive an HTML, a new page, so-called, you actually go to that page, which means that the page reloads. So that was not a really good solution for the actual applications, and the whole matter of naming the website and application was not even invented at that time. And developers were really frustrated with the way the web works, which is that you require static pages. And what if you don't need to request those pages? What if you need just some bare minimum data that gets updated on the UI side? That's it. So they came up with the SPAs, single page application, where you initially request the page, you render it. Typically, the page that gets returned to the server in terms of SPAs are really the minimal amount of HTML and mostly about JavaScript, which renders the actual view. And then at some point in that JavaScript, a huge bundle of JavaScript, I should say, there is a code that requests or that performs the so-called Ajax request. And this request gets us the data that we need, and then we're finished rendering. So that was not really convenient. And if I were to show you, there is a typical tool that we use in the development, not only in backend development. It's called Postman. And I think it's cross-platform, so you can actually use it even if you are using Linux or Mac for that. So, and what I wanted to show you is that when you actually type something in the browser and you make I already have the request ready for me. So when you actually type something like google.com in the browser, and you're actually making a GET request, which is a special type of special word in HTTP protocol that denotes what type of request you're making, so that the server knows what to do with your request. So when you make that request, you receive some data back, and typically it comes with the status OK, which is 200. And what you receive is a huge chunk of stuff that not really needed every time you render it. So there are styles, as you can see, and the actual HTML is quite big, even for google.com website. And if I were to make an Ajax request, so if I didn't want to actually make a full request for the whole page, I should go and make a special type of request, or request a special type of endpoint, so-called, that gets me the data instead of static web pages. So if we're not diving into Node.js, and not just Node.js or server programming in general, basically we can summarize the whole thing about the requests from the front end is that we either ask for static pages, static requests, static anything which is static, and we get some page returned, or we ask for dynamic data, which is actually making a GET request to an endpoint that returns not just the static HTML, but some kind of JSON data. And JSON is so popular nowadays when we get the Ajax standard up and running, is that JSON, like JavaScript object notation, is not just in the JavaScript world, but also in Python, Ruby, Java. It's just a standard way for um, transferring data from the backend to the front end in JSON format. So as we do those requests, there is a way for us to actually see that without having to actually write the request, the server itself. And a typical way in the whole front-end community is reached to JavaScript object notation placeholder, which is a tiny and very, very popular service that fakes the REST API. So with this REST API thing being those endpoints that gets us the data. So if I go to their website, JavaScript Placeholder, you can just type it in the Google and you'll find the actual link there. If I go to that website, it shows me some ways I can like do the request, and lots of resources. So all these resources, posts, photos, or albums, or users, while I'm typing and clicking on those links, I'm actually making those GET requests. And if I were to use the application I showed you before, Postman app, and do the same GET request, just changing the link where I go, I would actually get the 200 response and the JSON object back. So why am I showing the Postman to you? Because when it comes to integration with some kind of backend on the project, with any framework regarding like the library of frameworks, anytime you do a Ajax request, it all comes to making those requests with correct HTTP verbs to a correct link with correct headers, and the Postman tool just allows you to easily make those requests, controlling all the hidden and open headers, body. So yeah, a very handy tool, and I think that might conclude our demo of Postman, I suppose. Yes. So then, Fetch API. With the introduction of Ajax requests, I can use it in Postman, all right, and I can use the same request in the browser, all right. But how can I make those requests from within my code? So, for example, if I wanted to make a simple application with a button where I click the button and actually make that request to the server, JSON placeholder server, I need some kind of programmatic way to do that, and they actually showed you a way with Fetch. But Fetch, if you recall the JavaScript history, is not something that was invented really at the beginning of JavaScript. And even with at the time that Ajax was invented and introduced into the web, Fetch was not really a part of the documentation and the whole ECMAScript specification yet. So we needed some way to do the same thing. And in general, Fetch API was written using a first way of requesting the Ajax request, which is making an XML HTTP request. XML stands for Extended Markup Language, which was another way to make some kind of communication with the server. And HTTP, I showed you, this is just a notation that requests a link with the verb and some headers, and it makes the request really lean, and you get the response with the JSON data. And XML, which is extended markup language, they use some sort of tags, like HTML tags that were written a special way, and those tags or text were sent to the server. The server understands the same thing, the same XML, and then returns in the same format, the extended markup language format, the same data. So you were not getting a JSON, you were getting a special kind of document. So it was like a step before the JSON, which was HTML, then goes XML, and then JSON. But anyway, the first XML HTTP requests, they looked something like this. They were included in the JavaScript, and it looks like really old JavaScript, where you actually feature checking if the XML HTTP request exists in the Windows object, and then you make a active object that you are instantiating with different types of those XML HTTP requests. Then, when you do the whole thing with like preparation, you actually open the connection with the same get HTTP verb. You point it to a URL, and then once you request .send, that's the moment when you actually send the request. So it was really cumbersome and not really applicable, especially when you write a React application. Like, it's not really useful nowadays. And with the introduction of promises, we got rid of all this linear logic and callback structure of XML HTTP requests, and we got something like this. So the same thing, it does the same thing, but using a fetch API, which is built on top of promises. So if we were to break down the whole structure of fetch requests, it's simply link where the endpoint is located and the methods. Methods is optional if you are making a GET request. Then you get the response in the then and an error if it occurs in the catch. So quite useful. But again, let's go back to the example. I have a test app, which is a simple application. Okay, I'm going to launch my VS Code. And if you haven't seen the Create React app, don't worry, I will explain. It will be explained in one of the next lectures about React application. But the thing is, with Create React app, you actually get a full functional application. And if I were just to run npm start in the same folder, I would actually get the whole application running already without any code from my side. And it's actually described in the Create React app in the reactjs.org documentation, so feel free to go there. So we get the whole structure, and to make it more simple, if I were to add something new to this application, I would actually want to create a folder. Let's name it components, and then inside the components, I would probably do okay. Let's have a card component. And if you recall the previous lectures, I have a choice of either making a functional component or a class component. So if we look into the app component, it's actually a functional component, which is okay, but at the same time, I really want to do some magic, do some requests in the app component. So I would actually go and create the same component, but at this time I would use a special extension in my VS Code that allows me to create those functional components on the fly. And I think without the prop types, just the bare bone render. Yes, so this is gonna be app, and that's how I create it. And then I will go to the old app and I will just paste the whole thing inside, so it still renders the same thing. And now I will cut the required statement with the styles and logos, and then kill the previous one, rename a new one, and now I think we'll probably have the same React application, but with class component. Why do I want to do this? It's simply because I want to utilize those React lifecycle hooks. So if I were to use component mount and just console log something silly like I'm mounted this, I would see with some like little tiny delay the statement I'm mounted. So as I actually mentioned in the lifecycle hooks lecture, that there are several ways you can make the request. There's actually several lifecycle hooks where you can do those requests. But the thing is, one of the best places to start making those requests is componented mount. And if I were to go to, for example, posts and make that get request for the posts in that componented mount method, I would see nothing. Actually, I didn't render anything to the screen. So let's see the network, and I will filter for XHR, and indeed you can see that I'm making that post request, and I can expect those like the headers or the status methods, or maybe the request headers that I included, the response header that the server included. But most importantly, I can preview the whole thing inside my component. So I got a bunch of information, and the typical structure of the information is that I get the ID, which is quite useful, as we discussed in the previous lectures. I could use this ID as a way to identifying the components in the key attribute. And then I get a body and a title, so quite useful. And this is the same response that I get in the Postman. So if I were to, this is actually a development tools parsing the data for me and previewing it. As you can see, I get just the strings without any notations. So I know that the fetch request is I shall return any promise, and there is a catch which I like to write every time in case of emergency. So log error, just a good practice. And okay, let's see the data inside. So I'm using a programmatic way to get the data from the server. So I need to see what's inside the things that returned from the server. And if I just do this, I should be able to see the data column and the actual data itself. But at the same time, I'm not getting an array of responses that I see here. And why is that? Is that And basically, it's because the fetch returns um, a response, which is not literally the response that you are expecting, like this response, but a special object that wraps around the data that is actually returned from the server, and it's used inside the Fetch API for some helpful things. So if I wanted to actually see the array of data that I'm expecting, with Fetch API, I need to do some adjustments before that. And this adjustments is just I need to pass the JSON as actually a JSON. So I pass the JSON stringified version that gets returned from the server into an object-like things that I can use in React or JS in general. So this is a must-have way when you're using fetch. So, and if I go to our application, already seeing some data. So let's maybe include some styling to our component, to our application. Since I'm using Create React App to show you a fast way to develop some prototype application, I could show you a thing called Material UI, which is a material design React library, a very popular one. And to install such library or any other library for styling, if you don't really want to spend time on the styling itself, you can just Google one of those libraries, Material UI, and get the getting started section. So I'm going to install Material UI core like this, and while it's installing, I need some way to include the fonts that this library uses. And how can I actually do this if I don't really see any HTML in the Create React app? And it's actually what's funny about React is that if you recall the beginning section of React, you need to tell React where to go, where to mount itself. And I can tell from the index.js file, I'm mounting to something with ID root. So I must have some way of seeing the HTML inside this. And yes, that's actually that's actually how Create React App works, or any React application works. When you launch it using one of the scripts like start or build, you are before rendering something to the screen, you're actually building the application using something called Webpack, and it builds inside of a static file. It renders the whole like HTML that you had with the root element, and it includes some JavaScript that gets returned from the build step inside our application. And a typical place is a public. So, for example, if I were to build the whole application that I'm seeing now into a static files, those static files would be placed in the special folder called build with the HTML that I'm seeing here. So this is the root element that Create React App actually renders the whole application. So that's kind of a really nice place to place some fonts. Let's just experiment a little with, for example, adding exclamation mark so we can test that it's actually the same HTML that is rendered every time that we're rendering our SPA application. I should see the title right here, yes. So this is the place. So we just go there and grab the whole thing and paste it just above the React application. If I were to use this library, I also need some fonts, for example. And that's it. That's the best place. You can place all those HTML links to some fonts, external CSS files, or icons in the React while you're using React. And again, so I wanted some kind of list. So I would just search for either in this menu or using the search for list, and I get back with the list component, and I can see that I can have some kind of list looking like this. So they actually provide you with the whole code to render this list, and I can just grab it. As I can see here, they're using a functional component. So I'm going to just grab the whole thing, create a, let me just create a list.js for a moment. And I just paste it here without any additional modifications for that thing. And I will go and use this list, for example, on top. I don't know. Before I can do that, I would actually need to import the whole thing. And as far as I know, VS Code actually would suggest some stuff for me, but I believe not the stuff that I need. So anyway, this is how I include the component. I am bringing that component from as list from components / list. So that's it. The lines that I wrote is the import statement and actually used the component. Everything else comes from the library itself. So if I go to our application component list, draft icons. Oh, I see. So if I change the HTML, the underlying HTML, it doesn't get bundled at the same time, and that's actually a good thing that happened to me during the recording, because with this thing you actually can have a better understanding how React works. So public folder is just the static things that I get into. Okay, I think it's still not compiling correctly. Okay, I think I know that the card actually works fine because I tried it before our demo. Okay, copy the source. Let's go to the card component, paste it. I know it should work. That's a pity that the list doesn't work. But anyway, we'll get through with that. So I get card from components. And now I go and rename it card. I will stop the server so it doesn't really bothers me with the recompiling. Card and card. npm start. So the reason why I'm trying to import the hard element is that when you're building something and there are lots of places you need some kind of data inside, I wanted to show you that there are a couple of ways you can actually request the data, which is using a lifecycle method, as I'm doing here, and actually some hooks inside the functional component itself. So I'm getting the card itself. I guess it's a bit stretched out, as you can see, because of the amount of the width. What am I going to actually bother with that? I will just delete the whole thing from here so I can actually see just the cards itself. So I don't need the logo anymore. And yeah, I can see the cards. And if I were to paste it a couple of times, I would actually see a whole bunch of lines there, and let's try to make it a bit more apparent that we are actually getting the lines. So this is the class. If I were to add some margin with 10 pixels around each card, maybe even with 50, yeah, I get the results. So I will use class name for the cards, and I will make it apparent that this is actually a card, and I will add that line. Really, not really. Doesn't matter where I add it in terms of margin 50 pixels for each card, and make it actually a bit more correct this time. So, and I am adding the class to every element, and it looks cumbersome because I'm actually doing some logic. Okay, it does not apply. Maybe I need to consult the whole thing, how I can outlines. So they provide some way to actually do some stuff with it. And like this. That should get us a better view, hopefully. No? Barely visible, so okay. So when I get the data, I'm finished with the actual cards rendering, and you can see it's very, very inconvenient for me to actually change the whole thing on the fly. And if I go to the props of that component, I can see that to change the data that I'm seeing in the card, I need to actually provide some input inside of it. Okay. I think it was title. I don't remember where. Oh, live coding is not really a pleasant thing to do, I should say. Cards, yes, typography, learn more. Okay, yeah, I will do it manually. So if I were to, for example, change it to props.title and provide the card with props statement. And for example, typography, let's see, this is well meaningful and kindly. This could be a whole bunch of body for the card. So props.body be okay, yeah. Disappeared. Benevolent, we'll get rid of that. And we'll have hopefully more, yeah, concise way. So what I see here is that if I change the props for each of the cards, I will get some data inside. So for example, if I say A here, and all other components will receive some kind of props, and then I will say body could be lorem ipsum dollar bit met, if I remember. I would actually see the whole thing lining up nicely, and a very cumbersome way to do React is to write everything manually, so I don't really want that. What I want is to get some data returned from cards list, for example, and I would probably have some array of cards where I map each card, and the card itself that I get is an object, and I should return something like this, a actual JSX of the card itself with a card title, and body. Now, if I were to somehow let the data come to my state, for example, or the place I can store some data in my component and then actually render the whole thing in the render method. So I would actually see a whole bunch of new cards rendered. So this is the list, and I just do something like this. So I'm rendering a list. Currently it's empty list, so I won't see any changes. So I would see some kind of empty thing. But what I'm leading is when you make a request from component.mount, you can actually not just cancel log the data, but you can place data inside the component itself. And to do that, I'm going to use the set statement. And I would like for me to have for example, cards in there, and I just paste the data there. So a good rule of thumb is to create the state before you actually populate it and use some kind of default value for that. And as you can see, I get the cards as an empty array. And if I were to actually using the states like this and get rid of all the cards themselves, in a couple of seconds, I get a whole bunch of data all coming from that network request I made. And you see posts, they're actually the same. The first post starts with sent out, which is the same thing. And a very special way to see how React works is reading the warnings it says for you. It outputs for you in the console, and it says that each child in the list should have a unique key. And there are a couple of things that you can do about it in terms of a production environment. There are a couple of practices used, but the main thing, the main way you see that implemented in the real projects is that instead of coming up with a special way every time you have some kind of a list, you actually use the data that comes from the backend, because with the JSON placeholder, you get just a numeric increment every time that they return you data 1 or 2 or 3. It's not really useful. You can just use some kind of index in the map, but that would be a really bad practice. Most of the time, servers come up with something like a unique identifier for each data, and that data is actually written in some kind of database, and that ID is actually unique. It does not change every time you request the same data again and again. So that's a quite nice thing to provide for the React. And if I were to refresh, it's again trying to card list. I think. Oh yeah, no, not the key, but the ID. Yeah, and now it's happy. And if I were to go to the components itself and see what's getting rendered, I can see that each card has a very nice key thing and its name. And its name comes from the name of the component itself or from the display name that you specify. What I mean by that is that at some point I can rename the whole thing before I export it. using a display name. But anyway, we get something rendered. That's good. And now in this lecture, I will go to a more convenient way of requesting data, which is Axios. But before that, let's review what we did. So we have some logic that renders the data. We have some logic that requests the data, and the requesting logic is the actual fetch. If I were to, for example, if I were to use the fetch not in the component mount, but in the constructor itself, let's quickly try it out. So what would change? Some of you might know the answer, but the thing is, yeah, it must call super. Yes, I'm already forgetting that. Props and super with props. Yes, it looks kind of the same actually, but as you can see, this is the warning that we get, that we can't set the state when we are just building the object that the component will actually hold. So we don't have access to the whole thing yet. So that's not a really good place. What if we go to a render? Let's go to render. And looks kind of okay. Most of the time, developers see no difference when they actually making some requests in the render. And if I were to refresh the whole thing, I think we'll be all right. It's kind of hanging, and we can see why. It tries to make lots of requests instead of one. Why is that? Because you remember, when we're getting the data from the fetch, we're actually calling this set state. And it sets a new state. It updates the state. And we're expecting to update the state and get the actual like view that we need to render. But every time we update the state of a component, for example, this class component, at the end of the natively written set state function, this function, there is a update that is forced to a component, and the component re-renders. And what is re-rendering of a component? It actually calling the same render function again. So, and since we're calling it again, we are again evaluating the same logic, and it's not really good for us. As you can see, we're stuck. And at some point, I think this browser tab will just run out of memory, and that's not a really good place either. So we end up just using either component did mount or component did update for our things. So if I were to just copy the same code and use it as the component did update, yes, I am updated. What you'll see is that actually we're making two. Okay, yeah, it's still doing the same thing. I need to terminate the whole application because it's stuck in the loop of making the request and actually consuming the memory. So that's not really a good thing to see in production. So let's, while it's launching, let's think of what will happen. So we actually making some requests in component mount. We are calling this set state, which updates the state of the component, which is re-rendered, and re-rendering means that the component updated. And at the end of re-rendering, we will call this component update. And again, we will do the same thing. We will call for some API and then use this set state. And let's see what is happening. It should be okay, don't you think? Let's see the network attack. We're still getting the same request. Why is that? Same thing as with render, actually. We can't use something that requires re-rendering or requires updates in the component did update or render, because we'll end up in the infinite loop. So if I were just, for example, just to comment out the whole thing, and I would expect to see an updated state and a link. So yeah, I'm seeing 2 posts made, and if I were to just, for the sake of experiment, go to users, for example, I would actually see 2 things that I'm receiving. So with the fetch and the whole thing about making requests, remember 2 things. There are limited amounts of valid places that we can actually use to make those requests, no matter what library we're using for that. And a best places, or the most commonly used places, are component did mount and component did update. You cannot, you can technically use constructor or render or any other place, even the static methods of requesting some data. But you've got to remember that you cannot call the update of state. And if you're not updating the state or props of that component, what is the purpose of requesting some data? Maybe just to post some data, for example. Anyway, we are at the Axios library, and the Axios library is the same as Fetch API, which is based on promises. And internally, Axios is more convenient for us because with Fetch API, we are using a browser API. So it's one of those APIs that are written Fetch API. If we go to the whole MDN listing of APIs that the browser actually providing us with, there is a bunch of stuff that we're using. So what does it mean? Actually, we are using JavaScript, which is not part of our browser. We are using Fetch API in terms of we're using some kind of JavaScript browser to JavaScript binding for the API that the browser actually exposes, and it could be written in any language, C, C++, etc. So when we go from the browser to other places, for example, server, and we're using JavaScript on the server, we don't have Fetch API natively because we are not inside the browser when we cannot use its API. So at some point, it meant that we're stuck with XML HTTP requests, and that's where we, or maybe some kind of library built on top of XML HTTP requests for Node.js. It was something like HTTP module, or maybe some kind of isomorphic fetch. But with the introduction of Axios, we are actually back to a very nice and wonderful place of not caring what environment we are writing our code in. And if we were to use Axios, it actually knows and understands differences between different environments, be it a front end or back end, and it abstracts that difference away from us. So to summarize, we're making the same XML HTTP requests. We make HTTP requests from the node. Also, we use that convenient syntax of chaining .then or .catch statements, or like promises. But what Axios adds to the game is that we can intercept the requests and responses that we are making from the library. We're using some kind of building method. We can transform the request and response almost the same way we did with the res.json, but we'll see about that in a couple of minutes. We can cancel the request. For example, we want to leave the component that started the request. We want to unmount the component. So we have a way for us to cancel the execution of the request if it takes too long and we are already going away from the component, and Axios allows us to do that. It automatically transforms the JSON data. As you recall with Fetch, we needed actually an extra step of transforming res.json, the JSON data from the stringified JSON to the actual JavaScript object consumable thing. Axios does this for us. And client-side support for protecting against cross-site scripting, which is again some kind of building security mechanism inside the Axios. And those are the things that actually make Axios a great library for the API's purposes. And I think before that, I would actually go to the questions, and I see one of the lecturers actually helping me with that. Thanks for that. So this is a demo time again. So what I need to use Axios is simply, okay, I need to install it, obviously, install, or I should say npm I and Axios. I don't really care where I would use it. It should go to dependencies, I think, not the dev dependencies, because the whole application would actually use it in the runtime. So I'm installing it. And let's do a bit of cleanup before I do that. So, okay. One thing before I use Axios, if we take a look at the code that we have here, let's get rid of the code that we're not using, and we can review what we're doing each render. So if I were to go to the actual web and our application and see how much time it gets the rendering, I will record it and reload the whole thing. Oh, it actually crashed because I stopped the server. So npm start. Why am I doing this? Because I wanted to show you what happens when you are writing your requests or writing your consuming logic inside the render function. So I'll clean it and record it again and reload the page. And I think it's already up and running. If I were to stop, I see lots of stuff in here, but most importantly, if I were to see when I actually render the whole thing, so this is what I'm doing. I'm somehow evaluating the whole request response thing and then trying to render the whole component, and that's where I start actually rendering. So if you look at these numbers, and if I were to change something in the whole logic of my application work, I would go and extract the whole thing outside of my render and make it a not defined, called let's not define, because it should be like this. So most of the time I'm not really evaluating anything here, and as you can see, I'm not seeing stuff because this is not a function. So, but if I were to make it a function, and I will explain the purpose of that in a couple of seconds, and I'm calling this function every time I do the rendering, I might be seeing the same thing. So I start the recording, I get the data, stop it, and I'm trying to guess the rendering. Okay, let's do it clean, like this. Lots of the time, the data that you are extracting from the states, or maybe from some kind of array, and you're mapping through that data, is a bit more complex. And every time within each render to go through the data and to go through the data and evaluate the whole thing again and again, even with the slightest change, it's a bit more stretchy for our performance. So it's a good thing to hold it, for example, outside of the render method. But also, there are some things like memoization that could help us. So be aware of that. Do not store the logic of mapping through some kind of list of data, which could be quite huge, in the render method. Always extract it into a separate function so that in the end, after some time and the performance optimization hits the project, you can actually go inside your component and add that memoization stuff that instead of mapping every time, it could, for example, do a check somewhere in states, like with a ternary expression, where here you're actually returning the already pre-made array if nothing gets changed inside the data. So yes, with that out of the way, let's go and use Axios. So if we go to Axios library on the GitHub, let's close the performance tab. Yes, this is just a library that we installed already, and it's simple as that. We just need to call the Axios.get. Before that, we require access from non-modules, and as you can see, we're already getting some response without actually needing to pass the data before that. So let's just copy the whole thing and paste it here. So I'm making a request to some random stuff. So before that, I'm going to change the link. Let's keep it simple like this, and I'm going to bring Axios to the component itself. So if I were to, for example, pull up some data like this, or let's just, yeah, that's okay. And I don't want to console log this, and I want to get rid of the function because I like arrow functions more than just functions. They're much cooler. So like this, and data is not defined because this should be data. And I'm just console log comment out the whole fetch, and I should still get the same results. So the status map is not a function. So because I think that it lies under the data itself. Yes, and we get the same thing. So again, the request is the same. So we are actually requesting the same link with the get verb. The headers are a bit different. So because the Axios might include some headers differently from the typical fetch. But anyway, this is as easy as that. So at this point, using Axios, we got rid of one statement, which is not as cool as it might look. So, and that brings us to a much more detailed topic, including Axios, which is we would like to abstract away what methods of fetching the data we're actually using. And this could be done with the help of core module. So in most of the projects, you won't see the request made directly from components. And if I were to show you how you can use functional components to request the data, I just needed to copy the whole thing again and again. And if the endpoint changes, for example, this link change, it's not really good for reusability. So let's go and create a folder called core, and there we have we will have an API.js, and we'll have a couple of things here, like fetch get, Axios get, for example, and this functions would be just functions that return the promise that we can then use inside our components. So in fetch get would be something like this. This would be a URL, and since we know that it's a fetch request, we will just return this thing, and we will uncomment it out and replace the URL with like this. So might be convenient to look at this code like this, and for the Axios get, we'll have a similar structure so that I can show you the interchangeability of the APIs that are available for our reaching out to the web from React applications. And as you can see, I have one less code to write using this functions. And to use the Axios, I am going to import Axios from this. Come on. Yes. Thank you. And instead of using Axios now, I would just import some code from the core library that we are writing for our projects, and like core, and it would be API. So, and we'll have fetch get and Axios get, Axios get, and instead of making these cumbersome fetch requests, I'm going to replace it with fetch get and Axios get. And it might not look really much at the moment, but trust me, we'll get to the point that we actually make sense. So what's that? From Axios, what's passing error unexpected token, import Axios. Like the Axios library, why is that? Let's restart the server. It does not like Axios library. Imports maybe will just, I don't know. Maybe it needs a JS. Axios. Okay. So, and let's see if we're making actually those requests. Yes, the requests are made. So what's the difference? Now I can just use the same function without underlying logic and without knowing the underlying things anyway in our components. And just wrap, as I know that it will have some promise returned to me, I can just get .then and .catch statements added, and in those statements I would process the data in the ways that I like. So currently nothing much different from the fetch API in terms of there's -1 statement of transforming the data, and the data is not actually the array that we receive, but some kind of object that we need to call the .data thing. But we can have a whole API service here. and this will be an object. And this object will contain the init statement, for example, init method. And in that init method, we will do some logic that will help us to transform the Axios libraries or intercept the requests and responses. And we'll have those functions in the API service itself. I'm hoping that we can do something like this. I'm not really caring about not using functions, but the Create React app probably does not like it. So we'll just go with that and return like this. And same for the return here. And the API service is actually the object that we are exporting from this function. Export default from the API service. Failed to compile access get is not imported. API service access get. Yes. Why is that? API service. And then Axios dead and fetch.get like this. And now we have the same API service that we're reusing throughout the whole application. And anywhere I go, I can just use the Axios get or fetch get. And that brings me to the init function that I want to call whenever I start the project or the code, my repository. So I'm bringing the same API service here from .or API. Why do I need this? And you see, it still works the same way, so we're not losing anything. I want to utilize a special thing that the Axios library provides, which is I want to first create an instance of Axios with some kind of basic or base URL, I should say. And that instance could be reused in our Axios get or Axios or fetch get. With that instance, for example, if I just pass the code, I get the instance back, and I can actually store it in this .instance. With that instance, I could replace the whole thing, JSON placeholder type code, in the API service for the Axios, and always go to that URL. I will go and delete everything else. And then instead of calling Axios library, I will just call this instance .get. And if we look to the code and to the request that we are making currently, we're making the same requests and the URL is the same. But if I would just to go to the /posts, as you can see, we're still going to the posts. I will just delete everything else so that we can see a more clear picture. So with API service fetch get, we go and use the URL every time that we are using fetch, because we cannot have a base URL in fetch without additional coding from our side. But with API service Axios get, we can just provide the actual /something and go to that place without actually typing the whole base URL every time. So this could be your base URL for the API that you write, and then you request the data. With that, you can change easily the endpoints that you're using. So I'm waiting for both users at the same time. Yes. So let's change it back to posts and posts. And that's quite convenient with the Axios library. Another thing that we might do in the init function that we're calling in the index HTML, index.js file is that we can actually write some interceptors. So what is interceptor in terms of Axios? There is a bunch of logic, yes. So an interceptor is a thing that gets executed before something happens. So if I were to, for example, copy this code and reuse this code, but not with the Axios itself, but with my instance, so that my instance is actually the one that uses the functions. I can do anything here, actually. Console log hello from interceptor like this, and every time I do a request, any request actually, I would see something printed out to the console. So if I were to have an error, I would see that error. For example, if I can do something like this, hello from interceptor error, and then go to posts. I catch the error, and actually, since I'm catching the error outside, I'm not really using this interceptor logic. And this is interceptor logic for the request. So don't confuse the interceptors for the request and for the response. So if I were to name the whole thing like, for example, outside of my init function, I would create a const request interceptor success function, and then at the same time I would have a const request interceptor failure and replace it with a function like this. Then I will just provide the reference of those functions to both the interceptor success and the failure state. We will see a more concise picture, and it's much easier to read if I code it like this. So with this interceptor dot interceptor request, I have interceptor success and failure, request success and request failure. In the same manner, I can have a response. So if I were to write the response like this and intercept all the response errors and all success, I would have, since I'm using the same functions, I would have them run every time the failure happens. So I'm just renaming both functions as interceptor success and interceptor failure. And I'm replacing both of the methods here and here. We have two functions for success and for failure, both run for request and response. So now with this interceptors, if I make the request for posts, I would see first something gets printed out like hello interceptor once, then no failure in terms of firing the request, so nothing gets printed out on the failure. Then comes back the request, and we're requesting a wrong thing, so hello interceptor error happens. So, and as we're seeing in the console that we're making a successful request interceptor, and then hello interceptor error is a failure to do a successful response. So as you can imagine, there are these functions could be different functions. like for you to detail the way that the request intercepted separately from the response intercepted. So, but still, this is what Axios provides us with. With these interceptors, you can actually, before firing every request, without setting its headers, for example, you can set something in the request interceptor. For example, a typical use case is to to use something like this, a default token, authorization token, and we can have something like config dot like this, authorization or token is not defined. We will use like 1, 2, 3, 4, 5, and this is the token that gets set in M. Headers is not defined. Let's go and find what config is. The config order of presence. Okay. Config dot data that headers. Yeah. So with not defaults but headers. And authorization cannot set private authorization of not defined. Anyway, but this is the way that you are doing something in the interceptor. So this is a good place to set your auth logic here in the interceptor. And every time you make a request for the data or get the request from the server, your authorization token is sent with you. So I'm not going to dive deeper into the interceptors. And yes, this is it for cool features of Axios. And as you can see, we actually potentially could introduce some more logic for our API service to actually hide the fact that we're making the Axios request, because we can do something like just get and reuse one of the functions we defined here just by returning the chosen one from the function get. So if I were to do something like this dot Axios get and then use it in the way something like API service dot get and provide some URL. That URL is the one that we are using for our Axios get, and we're doing something like this. So we're reusing the logic. And for our application, and if I go and, for example, users, get users, I'm not really aware of how am I getting this users and what's actually needed to be changed every time that we are deciding to switch to another methods of reaching out to the web from the React application is actually just switching the method that we're using and still getting the same response, as you can see. So that's it for the Axios library. One thing to note is that with the app being a class component, and I showed you a different ways you can do the same logic in the app, in the class component, I wanted to point out that you can do the same kind of requests from the use effect hook, and this is the use effect hook. And if we go and grab some data from here, yes, this is a source. Okay, and if we go to a card component and we require the use effect hook from use effect, yes, that's it. Required it from there, and since we don't have any places better for making requests or making some kind of logic inside our functional components, but the body, I would just paste it here, and this is where I get the request. So I need an API service imported in the card function. I'll just import it right here, separating it from other libraries like this, and then go to API service, API service.get. I need to provide a new URL. Let's make it, for example, photos, and see what happens. Yeah, it just tries to do lots of things, updating it every time, I think. Are we properly subscribed? Oh, yes, that's the logic that needed to have been cleaned before I can use it for that hook. Okay. Can you stop for a second? It's not really convenient to do the logic. Classes are much more fine-grained, I should say, when it comes to deciding the places you can use the request logic. Yes, so this is it, and let's check if we're making the request. Or 100 errors. Oh my gosh, 100 errors. What am I making? Yeah, making lots of photos because I'm rendering it every time, and I should say I think I need to include some kind of check so that it does not render all the time. But no, that's actually really shows the difference for the between the class component and functional component with the use effect. This is evaluated every time that we are rendering this simple card, and we are rendering the card 100 times, and that means that we are requesting photos 100 times. And since we cannot extract this into a separate function call, or maybe instantiate the card component once and do the fetching logic there, and then reuse that logic, it requires a lot more like thinking and usage of different hooks, React hooks. I conclude that the React class components are a much better place for you to start doing the requesting and reaching out to the web, or using various methods that I showed you here, a bare bone Axios library, or even fetch API if you are so pleased, or maybe you can write a whole API service that abstracts away the way that we are making requests possible, or maybe even a base URL is abstracted using some kind of logic we are writing here. So feel free to choose wherever you like. In the production environment, most of the time you'll see the API logic is kept separately from the components, because it's not really a, I should say, not really a components concern in terms of business logic. But anyway, I hope you guys enjoyed the lecture. I hope it was really informational for you, not really confusing with my live coding. But anyways, maybe some questions. Okay. So, did you use npm install it? I don't remember. I think I installed the Axios, so it should work. In our homework, we're supposed to use WebSockets. Can you cover this as well in this lecture? Is this the topic for the lecture? The lecture about WebSockets should have happened already, I think. I need to consult the schedule to be really correct in this topic. But the thing is, usage of WebSockets, it's not really it's not really much different from just making a simple HTTP requests. I believe that WebSockets with React are used with the socket IO. Let's check it. Yeah, socket IO just auto-completed for me. So React socket IO. Let's see if we can break down the whole thing. It's not really much different. So with React, you have an access to, let's decline the cookies because I don't need them. With the React socket IO, you have a component that abstracts away the whole thing of setting up the connection and then actually polling for the updates from the sockets, or waiting for the server or for the other end to ping you, and you provide the URI, the same as I did, and that's it. If we're using sockets just simply without the wrapper component, so let's see. Let's go like here. Sockets IO, index HTML. So as you can see, it uses like an old way to have the connection set up. Let's see. It does not provide any data. Get started documentation. Demos of the chat. Okay, let's use source code. It's all part of the lecture, but I just want you to understand that it's not really much more complicated than the ways that I showed you the usage. Okay, this is a backend part. What about the front end? It was in the public folder, public main.js. Let's see. Okay, it's instantiated. Then I believe that if I search for socket, it will just send the thing. So if I were to map the whole socket thing onto the application that I showed you, I would go and set up the connection to a socket in the root file of your application, which is in my case index.js, because it's still not the React rel. I'm not rendering here anything, and it's already like evaluated. So it's like a first place where you do instantiation, as I did with my API service. You can actually go and instantiate the whole thing in the init functions, the way I did with the Axios, and then with all other methods that emit messages, you can have something like emit that, what's it say? It says what should I do, and the actual payload. So an ID and payload, and this will be like a function that will return this dot socket, for example, dot emit, and I will just pass the ID and payload like here, like this, and I believe it will return something like a promise, and the whole thing about the socket will be socket and let's say IO, yes, like this, IO. And I believe at some point you need to provide a URL or URI for the socket to start the connection. But the whole usage will be actually the same. As you can see, that's example app just emits the messages to the server, and then it like updates the instance once it receives some responses from the server. So don't worry, it's like the same thing. Okay, as for our homeworks, also the connection URI that we are supposed to use is not working. Can someone from Managed Organizer actually verify that? I will ping someone on the organizers part so that they can look into that. but I hope that you're not really scared about different protocols that we're using. So, just for you to understand, the whole lecture was structured as a way for you to be familiar how you can do the various requests from React and various ways, typical ways that you can make requests using Fetch or Axios or WebSockets. Uh, the difference between like Fetch, Axios, and WebSockets are just the protocol that they're using. The whole underlying architecture that you are implementing in your code stays the same. So you can abstract away that uh, so it all boils down to how you can architect the thing that it's the same thing instead of using HTTPS or HTTP protocol. You're going to use WS protocol, but the uh, approach will be the same. First, instantiate your connection or your instance of connection, and then do the requests or emit the messages. Okay, so that's it from my side. If you don't have any other questions, I think we might conclude this long demo live coding session. I hope you enjoyed it and see you guys in the next lecture. Thank you.